This is part 2 of section 4.1. We are now going to talk about the substitution method to solve systems of linear equations. Okay. What we're going to do is we're going to solve either equation for either variable. Often, as in this example, something will be done for you. On other examples, it will be really easy to get a variable alone. Okay. Then we're going to take and substitute this equation into the other equation. We're going to solve the new equation and back substitute. This will make a lot more sense after an example. Okay, so let's look at this first system. My second equation is already solved for y. So what I'm going to do is since I know that y is equal to 5x, even though I don't know what 5x is, I'm going to be able to take this and plug it in right there. Okay, so solve for either variable, that's done for us. Substitute this equation into the other equation, which will give me 2x minus, instead of y, I'm going to write 5x, equals 6. So that's the substitution step. Now I have an equation with just two variables, and I can solve this new equation. Combine like terms here, I get negative 3x is equal to 6. Divide both sides by a negative 3. And we get x is equal to negative 2. Now we've done half the problem. We know what our x coordinate is, but we need x and y. This is what we call back substitution. And I'm going to take this value of x, and I'm going to plug it into either equation. It should not, if this number is correct, it will not matter which one you choose to plug into. So choose the one that looks easiest. To me, this second equation looks easiest. My y is equal to 5 times negative 2. My y is equal to negative 10. Now, I said before that graphing is the language we use for these. We always write our answers as an ordered pair because wherever these two lines cross, that's our answer. We are constantly thinking of these as graphs that cross. So our ordered pair is always x and then y, negative 2, comma, negative 10. If I were to graph these two equations, then they would cross at precisely negative 2, negative 10. Okay? So let's try x is equal to 6y minus 2, and x is equal to 3/4 y. Now, to use substitution, we need to solve one of our equations for a variable. It turns out that both of these are solved for x, which makes it very easy. It doesn't matter which one you think of substituting into which, because you're going to end up with the same equation. You're going to end up with 3/4 y is equal to 6y minus 2. I mean, you could have written 6y minus 2 equals 3/4 y, but we know that that's the same equation. So to solve for this for y, I'm going to get rid of this fraction. So I'm going to multiply absolutely everything by a 4. 4 times 3/4 y will give me 3y equal to 4 times 6 is 24y. 4 times negative 2, that's going to be minus 8. Let's subtract 24y from both sides, and that gives me negative 21y is equal to negative 8. Now divide both sides by a negative 21. And we get the fraction. A negative divided by negative is going to be positive. And then I check to see if 8 over 21 will reduce any, and it will not. My y coordinate is 8 over 21. Now we found our y, we need our x. I need to take this and plug it back in somewhere. You might think that it's easier to plug in here since it doesn't have a fraction, but it's actually easier to go in here. If I take this fraction and plug it in here, I'm going to have to do a fraction multiplication. And then I'm going to need to get a common denominator and subtract. Here, even though this is a fraction, all I have to do is one multiplication. So I'm going to take this and plug it in here. X is equal to 3/4 times 8 over 21. The 4 and the 8 will reduce, leaving a 2 in the top. The 3 and the 21 will reduce, leaving a 7 in the bottom. So our x value is 2/7. Now we always write our answers as an ordered pair. A common mistake is to write the first one you get and then the second one you get. You know that an ordered pair has to be x and then y, so double check that. If you make a mistake, if you think you've done the problem correctly in my math lab and it counts it wrong, this is definitely something you should check to make sure you put the x first and then the y second. Okay? 1/4 x minus 1/5 y is equal to 9. We have the option of killing all the fractions here, but we might not need to, because I can see that this is going to be fairly easy to solve for y. All I have to do is to move it over to the other side. And then what I'm going to be putting in the y spot is a 5, so that fraction is going to go away. And then I'll have something that's a little bit easier to work with. I still maybe want to kill the fractions, but you wouldn't necessarily have to. You wouldn't be dealing with numbers quite so big. But because I know that's not the way you guys will want to do, I'm going to multiply this entire fraction by the common denominator, which is a 20. Okay, so this system will become 2 times 1/4 is 5x minus 1/5 of 20 is 4. 4y is equal to 20 times 9, which is 180. Okay, I'm going to recopy my second equation down here. And I can think of this as my new system. I want to use substitution, and this one is the easiest to solve. If I bring the y over here, I get 5x is equal to y. Now this is the equation I solved, so I definitely want to substitute into the other one. I'm going to take this 5x and I'm going to plug it in right there for that y. That will give me 5x minus 4, instead of y, I'm going to write 5x, is equal to 180. So this gives me 5x minus 20x is equal to 180. Combine like terms here, negative 15x is equal to 180. Divide both sides by a negative 15. And we get x is equal to negative 12. So we know our x value, we still need our y value. I can take this and I can plug it in anywhere I have an x and a y. I could plug it in here, here, or even here or here if I'm really confident that I did this conversion correctly. I usually go back to one of the original ones. I'm going to plug it in right there. 5 times x, which is negative 12, minus y equals 0. This gives me negative 60 minus y equals 0. And then if I move the y over to the right, I get negative 60 equals y. So if I were to graph these two lines, they would cross in the point negative 12, negative 60. And this in the previous problem, or the types of things I'm talking about the disadvantages of graphing, this would be, we would need a very large grid in order to see where these two lines cross. On the previous problem, we ended up with ugly fractions. It would be hard to read that off. Okay. All right, so let's solve this using substitution. It looks to me like it's going to be fairly easy to get x by itself from this first equation. So if I change that by adding 4y to both sides, this becomes x is equal to 4y plus 2. And now I can take all of this, since I know this is x and it came from the first equation, I'm going to substitute it in right there. That gives me 4 times x, but x is 4y plus 2 minus 16y is equal to 8. Let's distribute here. Sorry, over here. All right, that gives me 16y plus 8 minus 16y equals 8. And then these go away and I get 8 equals 8. Okay, so my variables went away. That tells me I have a special case. If you look at the special cases we talked about earlier, we said that if your variables end up canceling out and you end up with something that is true, we have a dependent system. If your variables end up canceling out and you end up with something that is false, then we have inconsistent. Well, so we look at what we had left. 8 equals 8. Well, 8 does equal 8. That's a true statement. So that means our answer is dependent. Okay, which means that these two things are the same line. We're going to be asked to write our answer in set builder notation. In my math lab, it will provide you with this part of the set builder notation. There's a blank here that you need to fill out. And what they want you to do is to look at these equations and pick and get one of them, they are the same line, one of them into standard notation. Remember, standard notation had several requirements. It was in the form ax plus by equals c. It had to be in this order with no fractions. The first number has to be positive, and it must be quote-unquote reduced. We have both of these in the correct order. No fractions in either one. First number is positive. One of these is reduced, and one of these is not. If you look at this, if I divide this by 4, and this by 4, then I end up with this equation. There's nothing that divides evenly into 1, 4, and 2, so this first equation is in standard form, and that is what I would put in this blank.